नमस्कार दोस्तों, एक बार फिर से आप सभी का स्वागत है इकोनॉमिक्स प्रिपरेशन के इस मैथमेटिकल इकोनॉमिक्स सीरीज में। लास्ट क्लास में हम लोगों ने टाइप्स ऑफ मैट्रिसेस की चर्चा करी थी। आज हम लोग उसके आगे बढ़ते हुए मैट्रिक्स ऑपरेशंस को देखेंगे। तो मैट्रिक्स ऑपरेशंस के अंतर्गत हम मेनली 3 से 4 चीज़ें देखते हैं। सबसे पहले तो इक्वालिटी ऑफ अ मैट्रिक्स हम समझेंगे, फिर एडिशन, सब्ट्रैक्शन और मल्टीप्लिकेशन विद द स्केलर देखेंगे और उसके बाद मल्टीप्लिकेशन इन मैट्रिसेस देखेंगे। ओके, सो लेट अस स्टार्ट विद द मैट्रिक्स इक्वालिटी। नाउ टू मैट्रिसेस A and B are said to be equal if they have the same order. Same order means if two matrices of same order means suppose I have been saying this is a matrix M cross N order and this is another matrix, suppose B, and this is matrix A, and this matrix is of order M cross N. If these two matrices are of same order, it means the number of rows of one matrix uh, will be equal to the number of rows of the other matrix, and number of columns of first matrix will be equal to the matrix number of columns of the second matrix. If this happens, then only we can say that the each element of first matrix will be equal to its corresponding element, is equal to its corresponding element of the other matrix. Now let us say, suppose I have written here A11, A12, A21, A22, and here I have written B11, B12, B21, B22. Then in this scenario, since both matrices are of same order, then we can write it like that. Matrix A of M cross N order should be equal to the matrix B of M cross N order, and this implies that A11 must be equal to the B11, and A12 will be equal to B12. A21 will be is equals to B21, and A22 will be equal to the B22. Okay, I hope this matrix equality will be clear to all of you. Now let us move forward for the matrix addition. Again, what is matrix addition? uh, by matrix addition we mean that if we have two matrix A and B and both must have same order, it means the number of rows must be equal to the number of columns for these two matrices, then their sum will be defined like this. Now the sum of the two matrices will be defined like this. What it means? It simply means suppose any matrix A I have 2, 4, 1, 5, and it is a 2 cross 2 order matrix. Okay, and another matrix B is like 4, 5, 9, 2. This is again a 2 cross 2 order matrix beta. In this situation, what we have, that both matrices are of same order, then their addition will be uh, uh, granted, and the A plus B matrix will be written as or find like that when we add the corresponding elements of both the matrices. तो दोनों ही मैट्रिक्स के जो करस्पॉन्डिंग एलिमेंट हैं बेटा, हम उनको जोड़ेंगे, अर्थात 2 + 4 हम करेंगे, 4 + 5 करेंगे, 1 + 9 करेंगे, and we have 5 + 2. So if we solve this, what we have? We have 6, 9, 10 and 7, and this will be our resultant matrix A plus B. okay, and the resultant matrix will also be of same order. Okay, so this is the matrix addition. Again, the matrix subtraction, again the matrix subtraction will be the same. If we have two matrices A and B of same order, then their difference will be calculated by subtracting the corresponding element, by subtracting the corresponding elements. Okay, तो ये इस तरीके से हमको प्राप्त होगा। एक एग्जांपल के तौर पे इसको भी समझते हैं। मैंने कहा 2 4 5 6 is the 2 cross 2 matrix A, and this is matrix B, which is 1 3 4 9. Okay, so while finding the A minus B, we must have to first see whether the order is same. Yes, here we have the same order. अब A माइनस बी जब हम निकालेंगे बेटा, तो हम क्या करेंगे, करस्पॉन्डिंग एलिमेंट्स को आपस में माइनस में करेंगे। अब ये है कि यहाँ पर मैट्रिक्स A का पहला एलिमेंट क्या है, 2, मैट्रिक्स B का एलिमेंट क्या है यहाँ पर इस पोजीशन पे, 1, तो इन दोनों का सब्ट्रैक्शन लेंगे। इसी प्रकार से यहाँ पर 4 माइनस 3, 5 minus 4, 6 minus 9. Okay, so what will be the result? 1 1 1 minus 3. Okay, this will be our resultant matrix of the same order, and this is known as matrix subtraction. Now come to the multiplication of a matrix by a scalar. Now if K is a scalar, scalar means it is a some real number, and this real number is being multiplied to a matrix A, like K into A, then we can obtain the result of this by multiplying that element to the each element of the multiplying that number to the each element of matrix A. Okay, and here mathematically we can write it like this. Now suppose we have K is equals to 4, and our matrix A is like 2 1 5 9. Okay, then if we have to obtain K into A, then this will be 4 multiplied by 2 1 5 9. When this 4 goes into the matrix, it will multiply to the each element. Now what we found, 4 into 2, 4 into 1, 4 into 5, and 4 into 9. Okay, so the resultant matrix that we have will be 8, 4, 20, and 36. ओके बेटा, तो जब हम किसी एक नंबर से मल्टीप्लाई करते हैं किसी मैट्रिक्स में, तो हम क्या पाते हैं कि वो जो नंबर है वो उस मैट्रिक्स के सभी एलिमेंट्स के साथ मल्टीप्लाई होता है। ओके, और हमारा रिजल्टेंट मैट्रिक्स इस प्रकार से हमको मिलता है। आई होप इट इज क्लियर। नाउ moving to the properties of matrix operations, these are the basic properties, uh, and here what we found that the commutative law is possible, is followed by the matrix operation for the addition and subtraction. Okay, and sorry, only for the addition. Associative law is also followed by the matrix operation for the addition. And additive identity of this, if any null matrix is being added to a matrix A, then we found the matrix A only, their addition will be this. And if we add any matrix A to the negative of its matrix, then their sum will be 0. This is very important. And scalar multiplication is distributive also. Now the last example that we have seen here, we have multiplied k into a. Now suppose that k is multiplied to the sum of a and b. In that case, that k first multiplied to the each element of the a, and again will be multiplied to the each element of the b, and therefore we have this kind of result. Okay, and this is known as the distributive multiplication is being followed uh, for the scalar multiplication in the matrices. Okay beta. Now uh, next topic is the matrix multiplication. So we'll start matrix multiplication in the next lecture because it requires a separate lecture. Till then, thank you and stay tuned with our new lecture. Thank you so much.